Hey guys, sorry I'm not there today, but what we're going to do is have a little review. Then you'll work on some problems as a worksheet, and then at the end of the period, you'll take a quiz, which is review from the last couple of days, including today. All right, here we go. Let's start off with our problems, such as how many words you can make from the word green. So, question number one, green. And hopefully you remember we just count them, there's 5 letters, so it's 5 factorial over the repeating letters. And there's 2 E's in this problem, so it's just 2 factorial. I'll just crunch this one out for you so you don't even have to. So punch it in your calculator, we get 60. What if the word's bigger? So this one I want you to try. Bookkeeper, Book, Keeper. Bookkeeper. How many words you can make using all the letters? Try it out. There are 10 letters, so it's 10 factorial. And downstairs, you put all the repeating. So I see 2 O's, 2 K's, and what else we got there? How many E's? 1, 2, 3 E's. Let's fix that K. And 3 E's. And the trick is make sure you put this downstairs in parentheses. You punch this in, you get 151,200. Then we had problems using the combinations that we were using for the last couple of days. So for yesterday and today. So let's try combinations. So here's question 3. This will have a couple of parts. So let's say we have 5 boys, 3 girls. And we're going to make a committee of 4. Committee of 4. So we're going to have 4. We're picking 4 people total. So, part A. How many ways you have 2 boys, 2 girls? 2 boys, 2 girls. Try it out. And now remember, this is a combination, committees of combinations. So it's NCR. What you have, what you want. So I have 5 boys, I want 2. I have 3 girls, I want 2. So what you'd punch in your calculator is 5C2, which is 10, times 3C2, which is a 3, and the answer is 30. Now, what if we change this to a probability question? So what do we have? We have 5 and 3. So 5 boys, 3 girls. Okay, so let's change this to probability. Now remember, I want groups of 4. Group of 4. That's my number. All right. So now when we do probability, remember our formula we talked about yesterday, probability of an event is the size of the event over the size of the sample space. So what if we said, what's the probability of 2 boys, 2 girls? Now, I'm just going to set these up. I'm not going to actually crunch them out because you can physically type them in a calculator. What I really care about is can you set them up. That's the most important thing. Now, on your quiz, you will have to actually do the whole thing. You punch it all in your calculator. But for this, we're just going to set it up. So when I see probability, I'm going to think of a fraction. Now, we just did this two boy, two girl thing. So it was, what do we have? 5C2, 3C2. Now that's that's the number of ways. Now the total number of ways is how many people do I have? I have 8 people. I have 8. I'm picking 4. So this is what I would actually punch in my calculator. And whatever that works out to be, that's the probability. So let's call that question part A. So this is question 4. Let's try it again. Part B. Probability, all boys. Part C. Probability, all girls. And all you have to do is set them up. We're not going to punch them in, just set them up. I'm not going to give you a clue. All the bottoms will still be the same. 8C4. 8C4. All right, all boys would mean I want 4 boys. So it'd be 5. I have 5. I want 4 over 8C4. Probability all girls. Well, the problem is this. We don't have enough girls. So I don't even have to do this. This is crap. The answer is 0. It's never going to happen because the probability won't work. So that's probability using combinations. Let's try some harder problems. How about, the thing with restrictions. Those are good. So we have the word done. D-O-N-E. Done. How many words can you make out of it? How many words? 4-letter words. How many 4-letter words? And so it's just punch it in. 4 factorial. Whatever that works out to be. You don't even have to finish it. Let's try restrictions though. How many words start with a vowel? This is a restriction. So this is where you would do the letters like this. And we want a vowel. So we're going to think about how many vowels do I have to work with. There's 2 vowels, so I have 2 choices. And I just use one of them. It doesn't matter which one. Now I have 3 letters, 2 letters, 1 letter. This is an easy one. So 2 times 3 times 2. The answer is 12. Let's try it again. How many words start and stop, begin and end with the vowel? So set it up, crank it out. So here we go. There's 2 vowels, so I have 2 for the front, but I only have 1 left for the back. So those are done. Then I have 2 choices, 1 choice. Multiply them out using counting principle, and there's 4 possible combinations. What's the probability that it starts and ends with a vowel? So probability Begin, end with a vowel. Well, so remember our formula. The probability of the event, that would be this one right here. That's the probability of the event. So that's 4. And this guy up here, which we didn't do, was our size of our sample space. So what's that? Let's just do that. 4, 3, 2, 1. 12 times 2 is 24. 4 out of 24. Now remember, you don't have to reduce probability. And that's it. And one more. And then you're going to work on the review sheet. Now, there's a bank. Has a 7-digit entry code. And you have 2 conditions. And so you have to actually meet both of the conditions. So here they are. The first digit cannot be 0 or 9. So the first digit not 0 or 9. And the code cannot start with 8822 for some reason, I don't know, or it cannot start with 7733. All right. So we're going to treat this as 2 separate pieces. So we have a 7-digit code. 1, 2, 3, 4, 5, 6, 7. And so now this first one is no 0 or 9. So how many now digits go from 0 to 9? So if I'm only allowed to use, I can't use these, there's only 8 choices for the first spot. But the next number can be anything. So it could be 10, and I'm allowed to repeat, so it's 10s all the way across. This would be all the possible numbers if you can't start with 0 and 9. So 1, 2, 3, 4, 5, 6 zeros is 8 million possible numbers to start with. But now what I'm going to do is I'm going to get rid of these guys, any number that starts with an 8822. So let's start with, this must be an 8. This must be an 8. This must be a 2. This must be a 2. So what I'm going to do is I'm going to subtract off the bad numbers. Well, how many 8s are there? Well, there's only one 8. How many 8s? There's only one 8. There's only one 2. There's only one type of 2. And then the back parts, though, can be anything. So I have 10 numbers to choose from. So when you multiply this out, you get 1,000. Try the next one. What you can say, it's exactly very, very similar. Only one choice is for those numbers. 10s. So this makes 1,000. We're going to subtract these numbers off. So our final answer is whatever 8 million minus 2,000 is. So we get 7. Oops. Let's put it in the right spot. 7998. And that's it. Now there's a worksheet, which these questions came off of. Most of these questions came off of. So don't redo the same questions. Just work on them. And if you want, you can just set them up. You don't even have to finish them all up. Just make sure you can set the questions up. The answers are going to come up on the screen. So somebody just press pause, give you guys a few minutes, 5 minutes before. Now remember, you have a quiz at the last 10 minutes. So Like, give yourself until 15 minutes, then take a couple minutes and start going through the answers. And then just do your best. All right, guys? There's a homework sheet, which is mixed review. It's more probability. And see you on Monday. Have a nice night.